In this video we're going to look at angular measure, which is just measuring angles. Now in the past you've probably used to looking at angles and measuring it in degrees. So for example, you know that 90 degrees kind of looks like this. It would be 90 degrees if you do something that followed that trace. So you would know that this angle in here, from here round to here, that angle would be roughly 30 degrees. Now, there's no particular reason for 90 degrees to look like that. Somebody at some stage in the past just thought that a whole rotation should be 360, and they called that 360 degrees. But there are other systems. Some systems go around 100. I think it's Radians do that, but that's never used these days. But the most common measure in mathematics for angle isn't degrees, it's actually something called radians. And to get the radians in an angle, what we look at, or what we can look at, is imagining that this arc here, this little thing that's labelled with the S, is part of a circle that goes all the way around like this. And just if you want to get this angle in radians, all you have to do is to do the arc length here, whatever length S is, and divide it by R. Right, so just whatever the length of S is, divided by R, gives us the angle in radians. Now, if you're not used to this symbol here, this symbol, it's the Greek letter theta, and it's often used to represent angles. So if you're finding angles, often this letter is used. Okay, so in example 1, you're told that there's a sector of a circle. This is an example of a sector of a circle, and it says that the sector has an arc length of 1.8. In other words, this part here is 1.8. And then it says if the radius is 6, so here, this part here is going to be the radius is 6, what is the angle of the sector? So we're asking, what is this theta? What is the angle of the sector there? So all you have to do is use this formula here, theta equals S over R, and just plug those numbers straight in. So when you do that, what we should get is 1.8 divided by 6, and if you do that calculation, then what we should get then is 0.3 radians. It'll be a different value in degrees, but in our new mathematical kind of measurement of angles, it's 0.3 radians. I know it seems a bit strange to be using a different unit, but it's a little bit like if you're measuring length, you can measure length. If you're American, you might measure length in miles or feet or inches. But if you're European, you might measure it in meters or centimeters or kilometers. So depending on who you are, you might use different units. Radians are useful, especially in calculus. It makes life a lot easier in calculus. Now, in example 2, we're told that there's a garden that's the shape of a sector, so it's in this shape here. And we're told that the angle down there is 2.5. What we're asked for is what length of fence we would need to enclose this sector. So it would be this plus this plus this, S plus 15.4 plus 15.4. So we need to find out what S is, but that's easy because all we have to do is multiply the radius times the angle in the middle. Right? So if we do that, it's 15.4 times 2.5. And if we do that calculation, it's 38.5 meters. However, that's only this part here. It's only the S. So if we want the total length of the fence, that's this plus this plus this, we have to then add on 15.4, but 2 of them, plus to the 38.5. And if we do that, what we should end up with is 69.3 meters. Now, it's often useful to be able to convert between radians and degrees. Now, if I just remind you, you might remember from your days doing geometry that the circumference, if you drew a circle, the circumference of a circle would be 2 pi r. All the way around the circle would be 2 pi r. That means that if you divided the whole circle by the radius, you would get 2 pi all the way around. So, in other words, a complete rotation all the way around the circle would be 2 pi radians. So that's 360 degrees. If 2 pi is 360 degrees, then pi radians is going to be 180 degrees. That means that roughly 3.14 radians is 180 degrees. So if you want to convert between radians and degrees, well, 1 radian is going to be 180 degrees divided by pi, right, which is this equation here. 1 degree, if you want to get 1 degree, you'd have to divide this by 180. You'd have to divide pi by 180. So 1 degree is equal to pi over 180. If you want to get a certain number of degrees, like if you wanted to get 5 degrees, you would have to do pi times 5 divided by 180. And that would give you the number of radians. In the same way, if you want to convert radians into degrees, take your number of radians, multiply it by 180 and divide by pi. Okay, so if you want to convert 25 degrees to radians, we've got to put it into this equation in here. You've got to multiply the 25 by pi and divide by 180. So if we do that, what we should get is this. And if you simplify that a little bit, you get 5 pi over 36. Often we just leave it in terms of pi, we just leave it as 5 pi over 36, or we try to simplify it. And so usually we won't go any further than that, but if you want to, you can convert it into a decimal. Now, if you want to convert 1.3 radians into degrees, just plug it into this equation here. So in this case, that would be 180 times 1.3 divided by pi, and then you could do that calculation. It will give you 74.48 degrees.